Today we are going to cover section 1.1, real numbers in the rectangular coordinate system. So we're going to cover two topics in section 1.1. Take the time to copy down your title, your essential question, how do you locate points and find the distance and midpoint between 2 points in the Cartesian plane. Go and glue or copy your cutout and we'll start once you're ready. Go and pause it. Excellent. So in this case, real numbers. All numbers are either real numbers or non-real numbers. So today we're going to concentrate on the real numbers. Real numbers are those that can be represented by points on a number line and can be expressed as decimal numerals. So anything that can be expressed as decimal numerals or can be placed on a number line are considered real numbers. First, let's look at the natural numbers. The natural numbers are all the numbers starting with 1, 2, 3, 4 all the way through. Notice that 0 is not considered a natural number, but 0 is a whole number, and whole number also include all the natural numbers. So some of the examples are over to the right, including 3 squared, because 3 squared will be 9. So 9 is a whole number, but 9 is also a natural number. Integers. Integers, we're going to include all the whole numbers, but also includes the negative numbers. So 0, 1, 2, 3, 4, or 0, -1, -2, -3, and so on. And there's some examples on the right hand side. Rational numbers. Notice that you will start to see this notation on the next section. This is a set notation, and the little bar, this bar here, is read as such as. So therefore P and Q, such as P and Q are integers, where Q is not equal to 0. So 0, -5 or 6, anything they can write down as a fraction, but whenever you type it into a calculator, it's going to give you a decimal that will not be repeated throughout. So for example, 5 divided by 6, or we can type it as a fraction, 5 divided by 6, and if I place as a decimal, that is considered a rational number because the 3 continues and repeats throughout. Once we get to 22 over 7, 22 over 7 used to be a number that used to be to approximate the value of pi. Change to a decimal, 3.14. Notice that once it gets to after the 7, it's going to repeat 1, 4, there'll be 2, 8, 5, 7, 1, and so on. So therefore, 22 over 7 is also a rational number. So anything that can be expressed as a fraction, but whenever you type into the calculator, it's going to give you a repeating decimal. Irrational numbers are all the numbers that are not rational. So all the x's, all the values of x, such as x, is not a rational number. So square root of 2, if you type into a calculator and we place as a decimal, notice that it gives you a decimal, but it doesn't have any repeating digits. That's an irrational number. A famous number that we know is pi, 3.1415926535. The cube root 7. There's another irrational number that you guys covered last year. Do you remember another? Correct. E will be another irrational number. And E is 2.7. And if we type it into the calculator, E to the power of 1 will give you the value of E. We should have said 2.72 but this is the entire number. Notice that it kind of seems that it repeats, but it doesn't. The repetition kind of breaks over on the right hand side. So it is an irrational number. And real numbers are all the values of x, such as that x is a decimal number. It doesn't matter whether they repeat or not. So therefore, all the numbers above are real numbers. So let's go through example number one. Go ahead and copy it down, and then we'll start once you're ready. Go and pause it. So classify each element. So let's start with negative 3. We know that negative 3 is not a natural number, it's not a whole number, but it is an integer. So therefore, negative 3. If it's an integer, then it's also a rational number. It's not an irrational number because we type it in calculus, there's no repeating decimals. Well, there's no decimals period. But it is a real number. 7/3. 7/3 is not a natural number, it's not a whole number, it's not an integer. It is a rational number. It is not an irrational number because if you type into the calculator, 7/3 will give you 2 1/3, so it'll be 2.333333. It has a repeating decimal, so therefore it's not an irrational number, it's a rational number. And it is a real number. All of the numbers that we cover in Algebra 1 are real numbers. Then you start to cover non-real numbers once you start to cover the number I. But for now, we're just going to keep it with real numbers. So let's say 2.5. 2.5 is not a natural number, it's not a whole number, it's not an integer. It's a rational number. So therefore, it's not irrational, but it is real. 0. 0 is not a natural number, it is a whole number. Therefore, it's also an integer. Therefore, it's also a rational number. It's not irrational, and it is real. E is not natural, is not a whole number, is not an integer, is not a rational number, it's a irrational number. Square root of 81. Square root of 81, we can simplify the square root of 81 as 9. So therefore, the square root of 81 is a natural number. Square root of 81 is also a whole number. It's also an integer. It's also a rational number. It's not irrational, but it is a real number. Square root of 12. We can simplify square root of 12. We can break it down as the square root of 4 times the square root of 3. So therefore, square root of 4 is 2, square root of 3. Square root of 3 is an irrational number, so therefore that makes this square root of 12 as an irrational number. And it's also a real number. And the last number is 0.354. It's a decimal, so we know it's not a natural number. We know it's not a whole number, it's not an integer. It is a rational number because it stops and it does not repeat throughout. It's not an irrational number, but it is a real number as well. So let's continue to some definitions that we have covered before in Algebra 1 and Algebra 2. Go ahead and take the time to copy it down. Go ahead and pause it, and we'll start once you're ready. Go and pause it. So the Cartesian plane. So we have a Cartesian plane. The rectangular coordinate system, or the Cartesian plane, is formed by two real lines, x and y axis, intersecting at right angles. The point of intersection of those two axes is the origin, and the two axes divide the plane into four parts called quadrants. So go ahead and take a read through this once again and label everything that they talk about in this diagram. Go ahead and pause it, and I'll continue once you're ready. Go and label everything. So let's see. It is formed by two real numbers, your x and y axis. So therefore, we know that this is your x axis, and we know that this is your y axis. And it's intersecting in right angle. The point of intersection of those two axes is the origin. So therefore, this point here we call the origin, 0, 0. And the two axes divide the plane into four parts called quadrants. This is quadrant number 1. This is quadrant number 2. This is quadrant number 3. And this is quadrant number 4. So let's talk about an order pair. We know an order pair is your x and your y. That is a specific point. And now let's go over the definition of a Pythagorean theorem. Go and copy it down, and then we'll go derive the distance formula using the Pythagorean theorem. Go and pause it, and we'll continue once we're ready. So Pythagorean theorem. In a right triangle, the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. And you guys proved your Pythagorean theorem back in 8th grade. You guys proved it in several manners, several ways. And they're talking about the legs. So therefore we have a leg this is a leg, this is the other leg. And the hypotenuse, it always has to be opposite the right angle. So your hypotenuse is here. We also know that is the longest side. So from there, let's go and develop the distance formula. So do you remember, you guys have seen the squiggly lines before, correct? So you have your x-axis, your y-axis, but there's some squiggly lines. What does that mean? Do you remember? Correct. That means that it doesn't start, so therefore this point here is not necessarily 3, 2. There are jumping a specific amount of points, whether it's 5, 10, 20, 1,000. So therefore we're going to label this as x1. And same thing happens on the y-axis. We're not too sure what this point is located. It's going to be y1. It's going to be a first point. This will be x2 and y2. It doesn't necessarily need to be a specific amount. It's just a location. And now what we're going to do, we are going to build a right triangle. So therefore I'm going to draw a triangle. And because we're using the grid, we know that that's a right triangle. And what I'm trying to find the distance between those 2 points. So therefore I'm going to use my Pythagorean theorem. But instead of writing a squared plus b squared equal to c squared, I'm going to write down c squared is equal to a squared plus b squared. And I'm trying to find the distance, so I'm going to label this as d squared. So this will be d. Let me just leave some space. This will be a, and this will be b. So therefore, how do I find the distance of a? How far are they from each other? So if I was going to count, if this was happened to be 2, and this happened to be 3, 1, 2, 3. It's not, but if it was, and this 4, 5, 6, 7, 8, what will be the distance? The distance will be 1, 2, 3, 4, 5, correct? But another way of doing it is will be 8 minus 3 will give you 5. So we know that this is x1, and this point here is x2. So therefore, the same way that we did 8 minus 3 will give us a distance of 5. The distance or the length of A, the distance between this point and this point will be x2 minus x1 squared. In the same manner, what is the distance of this point? What is the length of side B? Will be y2 minus y1, right? Where this is y1 and this will be y2, so it'll be y2 minus y1. And now to be able to solve for d, we're going to take the square root on both sides. So therefore, the distance is equal to the square root of the difference of your x's square plus the difference of your y's square. And that is your distance formula. So therefore, take the time to copy down your or paste your cutout or copy it down and write down example number 2. Go ahead and pause it. So find the distance between the points. So we're going to use our distance formula. So find the distance using the distance formula, and then we can compare your answer afterwards. Go and pause it. Excellent. So in this case, your distance formula, and make sure that you write down each of the steps, and you also need to be able to see the setup. So it'll be the difference of your x's square plus the difference of your y's square. So your x's will be x2 minus x1, where this is your first point, xy. This is your second point, x2, xy. This is your first point. This is your second point. So it'll be x2, which is negative 3, minus x1, so it'll be negative 7. Double negative becomes a positive. Y2, which will be 3, minus y1, which is 1. So I do need to be able to see the first step as you work through your homework. So your distance, negative 3 plus 7 will be 4. So therefore will be 4 squared. This will give me 2 squared. The distance is 16 plus 4. Your distance will be the square root of 20. And I need you to be able to simplify the square root of 20. Well, I know that the perfect square that divides 20 will be 4. So square root of 4 times square root of 5 is 20. The square root of 4 is 2, so therefore there'll be 2 square root of 5. Letter B. So try letter B, go and pause it, see what you get, and we can compare our answers. Excellent. So this is your first point, xy. So x1, y1. This is your second point, so x2, y2. My distance is the square root of the difference between my x's. So it'll be 2 minus -1 square, so we can say positive, plus the difference between my y's, y2, negative square root of 3, minus, I'm going to simplify, so that will give me 2 plus 1 is 3, plus, what is negative square root of 3 minus 2 square root of 3? So in this case, you have to think that there's a coefficient in here of 1. Therefore, -1 minus 2 will be -3 square root of 3. And this is still b squared. So therefore, distance is square root of 3 squared is 9. How do I simplify this section here? So how do I simplify -3 square root of 3 squared? What do you get? Go and pause it, see if we can figure it out. Correct. So whenever you have -3 square root of 3 squared, and let me do that on the left hand side because that's something that will be on your test. That's many of you guys will get incorrect. So back in algebra 1, on your properties of exponent or algebra 2, you know that the square belongs to them both. So therefore, this is -3 square and square of 3 square. -3 square is 9. The square root and square cancel, so that gives me 3. So therefore, that gives me 27. That'll be plus 27. 9 plus 27 will give me 36. And the square root of 36 is 6. Example number 3. Go and copy it down, and we'll start once you're ready. So go and pause it. Show that the points 4, 0, 2, 1, -1, -5 are vertices of a right triangle. So let me make an x and y axis, and let's go and plot them. And I'm just going to make a 5 by 5. That's all I need. So 2, 4, 5, 2, 4, 5. Make sure that you guys are using a ruler when you are graphing or making a graph. So my first point is 4, 0. Second point is 2, 1, to the right and up 1. Next point is -1 and 2, 4, 5. So let's see, we have a triangle with all 3 sides. And if you notice, I need to be able to prove that this is a right triangle, so this should be the right angle. So how can I prove that? Well, I can assume that that's a right triangle, so therefore I need to get rid of that. It seems that's a right angle, but we need to prove it. And how can we prove that that's the right triangle? Let me label 4, 0, 2, 1, -1, -5. So how can I prove that this is a right angle? Well, if you work with vectors, we can prove it using vectors. But at that point, we need to be able to figure out dot product. And that won't be until chapter 11 or 12. But for now, we're going to find the distance of all 3 segments, or the length of all 3 segments, using your distance formula. And then using Pythagorean theorem, we can prove that that's a right triangle. So first, let's go and find the distance between the shorter side. So this will be, let's go and call this A, B, and then we're going to call that C since we kind of think that that's the hypotenuse. So we have A is equal to the square root. So find all three distances, see what you get, and then we can compare our answers. Going to pause it. So this case will be 4 minus 2 squared plus 0 minus negative minus 1 squared. So A equals 2, that gives me 2 squared plus negative 1 squared. So A equals 4 plus 1, A equals 5, square root of 5. Now let's go and find B. B equals the square root. It will be the difference of your x's. So it'll be negative 1 minus 2. Notice that if you do 2 minus negative 1, you'll end up with the same answer. So this will be negative 1 minus 2 squared plus negative 5 minus 1 squared. That gives me negative 3 squared plus negative 6 squared, 9 plus 36, and this will be square root of 45. Now I can simplify it, but I'm actually going to leave it as that because it will make it much easier once I use my Pythagorean theorem. And let me find C. So it'll be negative 1 minus 4, or 4 minus negative 1, negative 5 minus 0. That gives me negative 5 squared plus negative 5 squared. So it gives me negative 5 squared is 25 plus 25 square root of 50. And I'm going to leave it as that as well. I'm not going to simplify it as 5 square root of 2. So therefore, if this is a right triangle, if I use my Pythagorean theorem, which is c squared is equal to a squared plus b squared, it should give me a true statement. So c is square root of 50 squared. A will be square root of 5 squared. And b will be square root of 45 squared. So that cancels, so it gives me 50 is equal to 5 plus 45. Therefore 50 is equal to 50. That's true. Therefore, the triangle is a right triangle. The points are vertices of the right triangle. So let's continue to the last example for today. Midpoint formula, you guys have seen also in geometry. Go and copy it down or glue your cutout. Example number 4, and we'll start once you're ready. So the midpoint formula is very straightforward. You basically just add the x's, divide by 2. So you take the average of your x values, comma, take the average of your y values, and that'll be your midpoint. So let's find the midpoint between A and B. So your midpoint will be the average of your x's and the average of your y's. Now in this case will be just x1 plus x2. Because we are adding them, it doesn't matter the order. It will be negative 5 plus 9 3 plus 3. So this will be 4 divided by 2 and 0 divided by 2. So therefore your midpoint will be 2 comma 0. Letter B, I'm going to find the midpoint. I'm going to take the average of your x's and the average of your y's. Go ahead and pause it, see what you get, and we'll compare our answers. So in this case, it will be your average of your x's will be negative 1 plus 2 divided by 2. The average of your y's will be 3 square root of 6 plus the square root of 6 divided by 2. That gives me 1 divided by 2. And 3 square root of 6 plus square root of 6 will give me 4 square root of 6. Remember, there's a coefficient of 1. So 3 plus 1 will give me 4 square root of 6 divided by 2. I can simplify this. So my midpoint will be 1/2, comma. When you divide, you're only going to divide your coefficient. So that gives you 2, and the square root of 6 stays as this. In the same manner that you only added your coefficients, you only divide your coefficient by 2. So that is the first lesson for this class. I'm going to take the time to do a 3-sentence summary or more, and this will be part of your grade for your notebook. Have a great day, and I'll see you guys next time.